Good morning, students. Today we are going to learn mode, one of the measures of central tendency. So before going to know about the definition of the mode, let us observe some examples. The shoe size data. A shoe store recorded the following shoe sizes sold in a week. So these are the sizes of the shoes sold in 1 week. That is 8, 9, 10, 8, 9, 9, 7, 10, 8, 9. If we observe this data, this 7 numbered shoe, this size 7 appears only once. Only once. If you observe size number 10, size number 10, so size number 10 appears twice in the data, 2 times. 10 number size, here we can observe 2 times. And if you observe the 8 number shoe, so 1, 2 and 3 times. So 8 number shoe we can observe it in 3 times. And if you observe the size number 9, so that is 1, 2, 3 and 4. So the number 9 here it is observed 4 times. So here which number shoe sold more times in the week? 9 number shoe. So this 9 is nothing but mode of the given data. That mode is equals to 9. And let us see one more example. The restaurant menu data is given here. A restaurant's daily sales show the following orders: pizza, burger, salad, pizza, pasta, pizza, burger, fries and pizza. This is the daily sales of a restaurant. And from this data, if we observe, uh, fries appears only one time, and salad appears only one time, and pasta appears only one time, and if you observe burger, it appears two times, and the pizza 1, 2, 3 and 4. So pizza appears in the above data, means in the daily sales pizza appears 4 times. So maximum number of times recorded in the data is pizza. So pizza is the mode of the given data. So by these two examples, how can we define a mode? So a mode is the value among the observations which occurs most frequently, means maximum number of times other than the remaining observations. Okay, a mode is the value among the observation which occurs most frequently, means more number of times than the other observations. Let us discuss finding mode of ungrouped data with examples. Find the mode of the following data. Here ungrouped data is given. The observations are 5, 6, 9, 10, 6, 12, 3, 6, 11, 10, 4, 6, 7. So from this data we have to find the mode. So observe these values. So identify which observation, means which value occurs more number of times in this data. So 6 occurs 4 times, 1, 2, 3 and 4. The number 6 occurs 4 number of times in this data. So that is the maximum number other than the remaining observation. So here we can write the mode of this data is equals to 6. In second question, observe the values 20, 3, 7, 13, 3, 4, 6, 7, 19, 15, 7, 18 and 3. By observing these values, we know that, see, 3 one time and second time and third time. The number 3 occurs 3 times, and one more number is also there, that is 7, 7, 7 and 7. So the number 7 also occurs 3 times in the data. So we can conclude that mode of the given data is equals to 3 and 7, the two numbers. The third question, if we observe the values, 2 occurs 3 times and the number 3 occurs 3 times and the number 4 occurs 3 times and 5 occurs 3 times and the number 6 also appears 3 times. Means all the numbers 2, 3, 4, 5, 6 appears equal number of times, 3 times. No one number occurs more times than the other observations. So mode does not exist because all the observations appear equal number of times. Now let us discuss to find mode of grouped data. This is the formula. Mode equals to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Here you have to remember the terms in the formula. Here L is there. So L means lower boundary of the model class and H is nothing but the size of the model class interval or height of the class, and remaining three F1, F0, F2. These three are F for frequencies. So F1 means it is the frequency of the model class, and F0 means it is also frequency of the class preceding the model class, and F2 means frequency of the class succeeding the model class. These F1, F0, F2 refers to frequencies. L is the lower boundary of the class model class and H is nothing but height of the class. Let us solve one question from exercise 14.2, sixth question. A student noted the number of cars passing through a spot on road for 100 intervals, each of 3 minutes, and summarized this in the table given below. So the class intervals are given as 0 to 10, 10 to 20, 20 to 30, up to 70 to 80, and the frequency values are given as 7, 14, 13, 12, 20, 11, 15 and 8. Here we have to find the mode of the given data. So first write the two columns, that is the given class interval and frequencies. So by observing the frequency values, what is the highest frequency value? So 20 is the highest frequency value. So let us consider this as F1. So F1 means frequency of the model class. The highest frequency will be always F1, and in that row the class interval is 40 to 50, so the lower boundary value is 40. So this will be considered as L for lower boundary of the model class, and the frequency of preceding of model class. So this 12 is nothing but F0, and the frequency of succeeding of the model class, this 11 is nothing but F2, and height of the class interval means the class intervals are given as like 0 to 10, So subtract the lower boundary value from the upper boundary value. 10 minus 0, it is 0. So height value is nothing but 10. So let us write the values again. L equals to 40 and F naught equals to 12 and F1 value equals to 20 and F2 value equals to 11 and height of the class intervals H equals to 10. Now let us substitute these values in the formula. So mode equals to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Let us substitute the values in the formula. So first we have L. L value is nothing but 40 plus, in the numerator we have F1. F1 is 20 minus F0. F0 value is 12 by, in the denominator 2F1 is there. 2F1 means 2 times F1, 2 into F1. F1 value is 20 minus, again F0 is there, F0 value is 12 minus F2 value is there, F2 is 11 into H. H is nothing but height of the class intervals, that is 10, equals to 40 plus, first simplify the numerator and denominator here. So what is the value of 20 minus 12? 20 minus 12 is nothing but 8, and the next 2 into 20, it is 40, and 40 minus 12, so it is 28, and 28 minus 11, so it is 17. So the denominator is 17 into, outside H value 10 is there. So it is equals to 40 plus, now we can multiply this 8 into 10, the two numerator terms. So it will be 8 tens are 80 by 17. So it is equals to 40 plus 80 by 17 value is nothing but 4.70. 4.70. So finally, the mode value of the given data is equals to, by adding these two numbers 40 and 4.70, we will get mode is 44.70. And here you can observe the model class is nothing but, the model class is nothing but 40 to 50. From this class interval only we have selected L value, lower boundary value. So the mode value always lies in this interval only. Our mode value is nothing but 44.7, that lies from 40, between 40 and 50. Let us solve one more question from that exercise. Fifth question. The given distribution shows the number of runs scored by some top batsmen of the world in one-day international cricket matches. The class intervals are given as 3000 to 4000 and 4000 to 5000, 5000 to 6000, like that, up to 10,000 to 11,000. And the number of batsmen, the frequency values are given as 4 to 18, 18 to 9, 9, 7, 6, 3, 1, 1. Now we have to find the mode of the given data. Let us take the two columns, class intervals and frequency, from the given question, and from the frequency values observe the what is the highest frequency. So highest frequency is nothing but 18. So consider this as F1. This is the model class frequency, and in that class interval 4000 is the lower boundary of the class. So L value is nothing but 4000, and the frequency of the preceding of the model class, the 4 is nothing but f naught, and frequency of the succeeding of the model class, this 9 is nothing but f2. And to find the class interval, the first class interval is 3000 to 4000, and subtract the lower boundary from the upper boundary value. So 4000 minus 3000. So the result is nothing but 1000. This is the height of the class intervals. Height equal to h equal to 1000. Let us write the values again. L equals to lower boundary value is 4000, and f naught value is 4, and f1 equals to 18, f2 equals to 9, and the height of the class intervals h equals to 1000. By substituting the values in the formula to find the mode, so it is equals to L value is 4000 plus the numerator f1 means 18 minus f naught is nothing but 4 by in the denominator 2f1 means 2 times f1. f1 is 18 minus f naught value is 4 minus f2 value is nothing but 9 into height of the class is nothing but 1000. So it is equals to 4000 plus, first we have to simplify this numerator and denominator values. So in the numerator 18 minus 4 is there. 18 minus 4 is nothing but 14, and in the denominator we have 2 times 18. 2 times 18. 2 into 18 is 36. 36 minus 2 is 32. 32 minus 9 is nothing but 23. So the denominator is 23 into 1000. So it is equals to 4000 plus, now you can multiply the numerator terms 14 into 1000. So that is nothing but 14,000 by the denominator is 23. So equals to 4000 plus the value of 14,000 by 23 is nothing but 608.69. So finally mode value is equals to, by adding these two values 4000 plus 608.69 is equals to 4608.69. So mode of the given data is 4608.69, and here you can observe the model class is 4000 to 500. From this class only we have selected L value. So the class interval is model class is 4000 to 500. The mode value should lies between these values only. Our mode value is 4608.69, lies between 4000 to 5000. Remember these points about the mode. First one, the mode is useful for categorical data where the other measures like the mean or median cannot be applied. Second one, the mode is the best choice in the situation which requires establishing the most frequent value or most popular item. For example, to find the most popular TV program being watched, the consumer item in the greatest demand means maximum most people are using, the color of the vehicle used by most of the people, etc. Third one, the mode can be located using graphical methods such as with a histogram. Fourth one, the mode is not affected by the extreme values in the data. In the same way, solve the remaining questions from the exercise 14.2. These are the questions from SSC previous public examination papers, and practice these questions also.